Today we are graphing transformations of the remaining trig functions, tangent, cotangent, secant, and cosecant. Yesterday we did transformations of sine and cosine. So today we're going to begin by focusing on tangent. Let's remind ourselves of a few things. What is the period of tangent? The period of tangent is pi. We're going to graph one period of tangent. So that's just one arm of tangent. So tangent, remember, tangent, like sine, goes through the origin. And it has asymptotes on either side. Since the period is pi, the asymptotes are going to be at all of the pi over 2's. So the one arm or leg of tangent here, it's one, remember tangent is always increasing, so it's one up and one on each side there. So it goes like that. This is one leg of tangent, okay? So what would it look like if, instead of the period being pi, what if the period was pi over 2? If it was pi over 2, it would still go in the it would still go through the origin, right? And we would still have asymptotes on either side. But now, where would these asymptotes be? It's not going to be negative pi over 2 to pi over 2 because that would make the period pi, and we want the period to be pi over 2. This will be a negative pi over 4, and this will be a positive pi over 4. That makes the entire period pi over 2. What if the period was 4 pi? We would have these asymptotes still. If the period is 4 pi, then this is going to have to be negative 2 pi, and this was going to have to be 2 pi. Okay? What if the period was 7? Well, if the period is 7, this is going to need to be negative 3.5, and this is going to be 3.5. So the distance between them is 7. The shape is still the same, just the period changes. Okay? So keep that in mind. When we're graphing transformations of tangent, keep this all in mind. Okay? All right. Let's consider a vertical dilation of the graph of tangent. So once again here, let's start with plain old tangent. Negative pi over 2 to pi over 2. Tangent goes through the origin. And here the amplitude, well, they don't call it the amplitude. The vertical dilation of tangent is just 1. So since tangent is increasing, it'll look like that. So there's tangent. What if there was a 2 here? Well, the period is not changing, so the period is still negative pi over 2 to pi over 2. And tangent is still going through 0 because there's no vertical shift. What changes, what this 2 does, is it changes, instead of going up 1 at pi over 4, we multiply that by 2. So we're going to go up 2. Instead of being at negative 1 at negative pi over 4, we'll multiply that by 2 and we'll be at negative 2 there. Doesn't it make sense that that 2 took this and it vertically stretched it? Do you see the vertical stretch? That's what that did. What will happen if it's a 1/2? Well, we still have these vertical asymptotes at the pi over 2's. We're still going through 0. But this time, instead of going at pi over 4, instead of going up 1, we only go up 1/2 and down 1/2 over there. So this, I think in Algebra 2 they called that a vertical compression. vertical compression of a half. We just call it a vertical dilation of factor a half. The factor is a half there. Okay. Now let's do several things. It's a tangent, okay, but it has a vertical shift and a horizontal shift. Remember, just think horizontal. When you see phase shift, just think horizontal. The vertical shift is down 2. The horizontal shift is right 1. So I use that to get my new origin. Down 2, right 1, new origin. And that's really important for tangent because tangent goes through the origin, right? So we're going through that point. Okay. I'm going to go ahead and draw my new center line, just like we did yesterday with sine and cosine, my new center line there. Okay. Now I need my period. Okay. B is pi over 8, right? The period, to get the period, I take the normal period for tangent and divide it by b. But what is the normal period for tangent? The normal period for tangent is pi, not 2 pi. 2 pi is for sine and cosine. The normal period for tangent is pi, and I divide that by pi over 8. These pi's are going to cancel, leaving a 1 on top. And then I multiply top and bottom by that 8, and I get 8 for the period. So the period is 8. So after 8 units, I will be back in the middle. And every 8 units, I am back in the middle. Every 8 units, I am back in the middle, right? Okay. Halfway between those, for tangent, I have a vertical asymptote. Yeah? Halfway between those, I have vertical asymptotes for tangent. Okay? Now, there's a 2 in front of here. The vertical dilation is 2. There's no reflection. Okay? So, halfway between my center and my vertical asymptote, I go up 2. On the other side, I go down 2. So my first period here does that. And then I can continue. Did I do something wrong here? Oops, yeah, right there, not there. Let me fix that. Not there. Okay. Like that. That looks a little stretched out, which it should, but okay. And then over here, 2 and 2. Well, that was a good curve. This curve is not such a good one, but anyway, whatever. Okay, and there's the graph. Let's do this one. Another tangent. Another tangent. So let's do our shifts first. Here we're going down 3 and left pi. Down 3, left pi. Down 3, left pi. There's my new origin. Slide this up a little bit. Okay. I'm going to draw my center line. Alrighty. Now I want to know my period. So tangent goes through here, right? So I know tangent is going to start right there. I want to know what my period is so I know where my next time I'm right at the same location. So let's see. What is the number in front of the x? The number in front of the x is 1. True? So the period is the normal period for tangent, which is pi. So after pi units, I am back here. So every pi units, I am back there. Okay? In between there, I have asymptotes. Okay, so my first leg here has a period of pi units. The asymptotes are pi over 2 on either side. Yeah? Okay, now I'm going to apply this negative 1/2. Vertical dilation is a factor of half, and there is a reflection. So instead of going, halfway between here, instead of going up a half, I'm going to go down a half. But only a half. I should be doing this with my other color here. Only a half. And so on this side, I'm up a half. So that first leg there, looks like this. And then we can repeat it. Alrighty. So there's the complete graph for that curve. Okay, let's do a cotangent. So for cotangent, first of all, what does that normal graph of cotangent look like? What's the normal graph of cotangent look like? The normal graph for cotangent has a vertical asymptote right on the y-axis, doesn't it? So wherever our origin is, it has a vertical asymptote right there. And then cotangent is always decreasing, isn't it? And it has another asymptote. The period is pi, so this is pi. 0 to pi for cotangent. Okay? Alright, shifting. Vertical shift is up 2. Horizontal shift is left 1. So I'm going to go get my new origin. Up 2, left 1. Up 2, left 1, new origin. I'm going to do my center line. Okay? Alright, it's cotangent, isn't it? So, I know I have an asymptote right there, right at my new origin. True? My starting point is actually to the right of that. Yeah? Let's find out how far to the right of that by looking at the period. Well, B here is pi over 3. So the period is the regular, the normal period, divided by B. I'm going to multiply top and bottom by a 3. The pi's are going to reduce, and I just get 3 over 1, which is 3. Okay. So from here, after 3 units, I have another asymptote. After 3 units, I have another asymptote. And every 3 units, I have another asymptote. Okay? Halfway between there, I'm going to be right on the center line. So halfway between there, I'm right on the center line. Okay. Cotangent is always decreasing. So, halfway between these two, I should be up, right? How far up? Well, there's only a 1 in front of there. So, and no reflection. So halfway between here, I should be up 1. Halfway between here, I should be down 1. And then I can draw that leg. And then just repeat it for the remaining legs that I can draw. There's that graph of cotangent. Let's do a secant graph. Well, to do a secant graph, remember we always start by doing cosine, because secant is 1 over cosine. So I'm going to first draw cosine, and that's going to help me draw this. Okay, so let's do our shifts and everything. Vertical shift is up 1. Horizontal shift is right pi. So I'm going to use those to get my new origin. Up 1, right pi is my new origin. Okay. So I'm going to go ahead and do my center line just like always. And now I'm focusing on cosine. Okay. Focusing on cosine. Cosine does not start at the origin, does it? It usually starts up 1. But it's not going to start up 1, is it? Because there's a 2 here. How far up is it going to start? It's going to start up 2. Up 2. Okay? Now, I need to know my period because I need to know how far to go over to get my cosine graph. So my period now, my period. So B is 1/2. The period is 2 pi divided by B. I multiply top and bottom by 2 here, and I get 4 pi for the period. So after 4 pi units, I'm back here. Now I'm looking at what I'm given on this grid, and after 4 pi units, I'm off the grid. So I'm just going to eyeball it. That looks like about another pi, so I'm going to go to there, right? Halfway between, so 2 pi units away, I'm halfway between those, and which means cosine is down on the other side, right? So this one curve of cosine, this is this one curve. Oh, I didn't do this right. Did that a little bit off. I knew it was a little off when it wasn't getting there. Let me go erase this here. Okay, so there is my one curve of cosine. I'm going to keep on going with that same pattern to get the rest of my cosine. Okay, so that was just cosine. That's what we did yesterday. Now I need to change it to a secant, right? So everywhere that cosine is on the center line, everywhere cosine is on the center line, I have a vertical asymptote. Everywhere cosine is on the center line. Okay. And now it gets super easy, because now all we have to do is draw our U's. So my first U is right here. My second U is right here, and that completed one period. Now I just have to finish my graph. So the only thing that is actually secant are these orange curves, okay? All the green stuff just helped me draw what is secant was. Okay. The graph below is the graph of, is this all I have? I guess so. Yep. Okay. Alrighty. Charlie wants me to give him a quick pet. I'll be right back. Alrighty. Okay. Here I'm giving you a graph, and I want you to tell me the equation. Specifically, in a multiple choice style question, the graph below is the graph of which of the following functions. So I'm giving you three functions, and which is it? Okay. Alrighty. Let's check this out. Well, I notice that all of these have a -1, don't they? Is the center line down 1 in this graph? It sure is. That center line is down 1. So that takes care of all these -1s. So far, all of them could be it. Okay? I'm going to check out this one. This has no horizontal shift. So since it's assigned, it would start right at the origin. And it does. Up 3. Does it go up 3? It does. The period is still 2 pi. That all looks right to me. This is true. That one worked. Okay. Let's do another one. This cosine one. This one does have a phase shift, a horizontal shift. Right 5 pi over 2. So let's go to 5 pi over 2. Here's 5 pi over 2. This would be its new origin, right? It's a positive cosine, and it is starting up 3. The period is still 2 pi. The period is still 2 pi. This one works too. What about this one? It's a negative sign, and we have to go left 3 pi. Left 3 pi. So left 3 pi would be right here. It goes through the origin, which it does. It's a sign, so it should. It's a -3. Is it going down 3? It sure is. It's going down 3. So this one works as well. All three of them work. So the answer here would be E, 1, 2, and 3. Okay? Now, in class, I would have you guys come up with some more equations for this curve. We could come up with some more equations. What if I said, give me a curve with give me the equation that has a negative cosine. If I needed a negative cosine, I would force my starting point to be one of these things, right? I might force my starting point to be right here. That would be a -3 cosine curve, true? The period is 2 pi, so I don't need a number in front of my x. My starting point is to the left pi over 2 units. So I would plus pi over 2 here, and then minus 1 for my shift down 1, for my center line being down 1. So this would be another curve. Okay? How many equations could we make for this curve? We could make an infinite number. Lots of shifts, negative a values, things like that. Okay, that takes care of all of our transformations of the trig functions.